1 gram of ammonium nitrate is decomposed in a bomb calorimeter. The temperature increases by 6.32 Kelvin. The heat capacity of the system is 1.23 kilojoules per degree per gram. The molar heat of decomposition of ammonium nitrate is. This is the experiment to find out the delta U in a bomb calorimeter, and the delta U is given by minus Z into T into M by W. Z is the heat capacity of the calorimeter and content, that is given as 1.23 kilojoules into rise in temperature is given delta T as 6.32. M is the molar mass of ammonium nitrate, it is 80 by W, weight of ammonium nitrate is gram. So this on simplification gives you a value which is equal to the molar heat of decomposition of ammonium nitrate, that is 621.89 kilojoules. So choice D is the correct answer. The free energy for the reaction having delta H is equal to 31,400 calories and delta S equal to 32 calories per Kelvin per mole at 1000 degree Celsius is. The free energy delta G is calculated using the Gibbs-Helmholtz equation. Delta G is equal to delta H minus T delta S. So this will be equal to 31,400 minus temperature is 1273 Kelvin into delta S is 32 calories. So this simplifies to minus 9336 calories. So choice A is the correct answer. For a spontaneous reaction, delta G, equilibrium constant, and E0 cell will be respectively. Now for a reaction to be spontaneous, delta G should be negative. So this is the most important condition for a reaction to be spontaneous. Delta G is equal to negative. Then we have a relation delta G is equal to minus 2.303 RT log K. So delta G depends upon the value of K. If K is greater than 1, this part will be positive. Logarithm of a positive number greater than 1 is positive. So delta G will be obtained as negative if K is greater than 1. If K is less than 1, logarithm of that number will be negative. Negative of negative becomes positive. So delta G will be positive and yes. So the first condition for a spontaneous process is this one, and this is followed by the thing that K should be greater than 1. Repeat, if K is greater than 1, log K will be positive and delta G will be negative. Similarly, delta G is equal to minus NF E0 or NFE. Then E should be positive. Then only delta G will be negative. So these are the three conditions for the reaction to be spontaneous. So choice A. If both delta H and delta S are negative, the reaction will be spontaneous at. So we have the Gibbs-Helmholtz equation. Delta G is equal to delta H minus T delta S. Here it is given delta H is negative, delta S also is negative. So negative of negative, this becomes positive, and reaction will be spontaneous only when delta G is negative. So for delta G to be negative, here delta H should be greater than T delta S, because this part is positive and this part is negative. So for the answer to be negative, delta H should be greater than T delta S, or temperature should be low. If temperature is very high, T delta S value will become greater. So when temperature is low only, the reaction process spontaneous. അപ്പോൾ ഈ പ്രോസസ് ഓർത്ത് വെക്കുക. ഡെൽറ്റ എച്ച് ആൻഡ് ഡെൽറ്റ സി നെഗറ്റീവ് എന്ന് പറഞ്ഞാൽ കുറവാണ്. അപ്പോൾ low temperature is the condition for spontaneity. The enthalpy change for the reaction del N2 plus 3H2 giving 2NH3 is minus 92.38 kilojoules at 298 Kelvin. Delta U at this temperature will be. Again, you have the equation delta H is equal to delta U plus RT delta N. Here you are asked to calculate delta U. So delta U will be equal to delta H minus RT delta N. So the delta N. So this will be equal to delta H minus 92.38 kilojoules minus R is 8.314 joules. This you are dividing by 1000 for converting it to kilojoules. Temperature is 298. Delta N, 2 molecules of the product, 4 molecules of the reactant. So 4 minus 2, this is minus 2. Right? Minus of minus will become plus. Here this will be minus 92.38 plus. This will be around 600. 6 into 8, 48. So this will be around 5 kg. A multiplication ഏകദേശം ചെയ്യുക. So the answer is minus 87.42 kilojoules.